Imagine keeping a really meticulous gardening journal for years, right?
Right.
And you reach number 961, only to have like a smartphone app look at a plant you've walked past maybe 100 times and basically tell you that your own eyes are lying to you.
Oh, man. Yeah. It completely shatters that illusion we all have of our own
Yeah.
expertise, doesn't it?
Yeah, totally.
I mean, you think you know your local environment, you think your pattern recognition is just perfectly dialed in, and then an algorithm forces you to look closer.
Exactly. And welcome to today's deep dive, everyone. Today, we're exploring a highly specific, unexpectedly profound entry from a dedicated gardener's journal.
Hmm.
The source we're looking at is titled Notes on Gardening, Part 961 by an author named Ang. And this was just published today, actually, July 20, 2026.
Fresh off the press.
Right. And what starts as this, casual walk past a quote-unquote roadside landscape, it turns into this incredibly rigorous botanical investigation. And I just love how much detail Ang extracts from an everyday encounter.
Well, the fact that we are on part 961 tells you pretty much everything you need to know about the observer here.
Oh, for sure.
We are dealing with someone who has built a really intense habit of relentless, disciplined observation. Like, this isn't a weekend hobbyist taking a wild guess at a weed,
Which is exactly what makes the initial mistake so interesting. Okay, let's unpack this.
Let's do it.
So Ang is walking past a roadside landscape, spots a plant, and confidently assumes it's the common beetle. Botanically, that's piper-betle. And here's the twist, it's not.
Nope.
It's actually wild beetle, piper-sarmentosum,
Oh.
which is also tagged in the notes as daun-kaduk.
Right, daun-kaduk.
And it's the botanical equivalent of seeing someone you think you know walking down the street.
Right.
You wave, you start walking over, and as you get closer, you realize, oh no, I'm waving at their cousin who just happens to have the exact same haircut.
That is the perfect analogy, because what's fascinating here is how the visual heuristics we rely on every day, they're incredibly efficient, but they're inherently flawed.
Right. Because we're lazy.
Well, our brains are lazy. Yeah. When a seasoned gardener looks at a roadside landscape, they're taking in the macro context. They see the vining tendency, this specific shade of green, maybe the general leaf shape, and the brain instantly categorizes it based on past experience to save cognitive load. The brain literally just says, hey, I've seen this shape 1,000 times. It's piper-betle. Move on.
Yeah, and Ang didn't just accept the correction easily either. I love this part. The notes mention that confirming the identity required, quote, numerous reevaluations.
Numerous?
Yeah, and that the AI kept insisting on Wild Betel. I just picture Ang standing on the side of the road, right, snapping a picture, seeing the result, and getting genuinely annoyed.
Oh, absolutely.
Thinking like, no, the AI is wrong, the lighting is just bad, and taking it from a different angle, trying to prove the machine wrong.
I mean, we've all been there with those Plant ID apps.
Yeah.
But that phrase, numerous reevaluations, speaks volumes about the current state of gardening and botany. Well, there is this deeply ingrained stubbornness when you have practical experience.
Yeah.
You trust your gut. But the AI doesn't have an ego, right? And it doesn't use those human shortcuts.
Right, it doesn't care that it's just a roadside weed.
Exactly. It isn't looking at the macro context of the roadside at all.
Yeah.
It's executing this pixel-level geometric analysis. It is measuring the exact angles of the venation, the specific ratios of leaf width to length,
Wow.
and all those microtextures that our eyes just naturally blur together in the sunlight.
It really sets up this fascinating tension. You have the human gardener who understands the holistic environment, and the AI, which operates as this unblinking, purely objective lens.
It forces the human to abandon their assumptions.
And once Ang finally concedes that the plant is daun-kaduk, the entire tone of the journal entry shifts. It's like the ego drops, and the intense observation really begins.
Yeah, the resistance is gone.
Right. Ang moves in for what the text calls a close inspection.
And the breakdown of the plant's physical anatomy from that point on is incredibly precise. I mean, Ang isolates the specific traits that distinguish this plant from whatever generic vining weed they initially thought it was.
So let's look at that specific anatomy Ang documents, because the imagery used here is incredibly vivid. Ang notes it has a carpet-like growth habit, forming a dense, low bush.
A dense mat, essentially.
Yeah. And zooming in closer, there are, quote, multiple bumpy fruit clusters. And then there's the foliage, which Ang describes as having a deep, quilted texture between the veins.
The contrast in those physical descriptions is striking, don't you think? You have the smooth, methodical geometry of a quilted leaf sitting right next to the chaotic, almost alien texture of these bumpy fruit clusters.
Yeah, and when I think of a deep quilted texture, I immediately think of the structural mechanics of it, like how a puffy winter jacket works, or how high-end upholstery
Oh,
feels.
the jacket is a great comparison.
Right, or even corrugated cardboard, like how corrugated cardboard is vastly stronger than a flat sheet of paper. Or how folding a surface allows you to pack way more actual material into the exact same two-dimensional footprint.
Yes.
So I have to ask, when a plant physically structures itself as this dense carpet with this quilted foliage and bumpy fruit, how do those specific physical traits dictate its use as a ground cover in a landscape?
That is the million-dollar question.
Right.
Because it feels like the plant is manipulating its own surface area for a specific biological advantage, rather than just, growing a larger, flatter leaf.
Right.
If we look at the mechanics of understory or low-growing plants, surface area is the primary currency for survival. The wild beetle isn't competing in the upper canopy for direct sunlight, right?
Yeah.
It's way down low.
It's stuck on the floor.
Exactly. It is monopolizing the ground level.
Oh.
So by developing that deep corrugation, that quilted texture, the leaf drastically increases its total surface area containing chloroplasts without needing to extend its physical edges wider.
Oh, wow. So it's packing more solar panels into the same square footage.
Precisely. It captures ambient, scattered light much more efficiently from multiple angles.
It's maximizing its solar intake without taking up more horizontal space. That's genius. And I'd imagine that quilting also plays a massive role in water management, right?
Oh, definitely.
Because if you have these deep valleys between the veins, you essentially have a built-in drainage system, like to channel water down to the root base or to shed excess moisture quickly so the leaf doesn't succumb to fungal issues, especially in a really humid environment.
Yes. Both light capture and water shedding are critical for a plant that forms a dense, low bush. Which brings us to that carpet-like growth habit, Eng noted.
The living rug.
Right. That physical structure completely dictates its role in the landscape. A carpet-like growth isn't passive. It is a highly aggressive, highly territorial strategy.
Because it's acting as a living mulch, it's just blocking out everything else.
It completely shades the soil underneath it. By monopolizing that lower vertical space and weaving itself into a dense mat, the wild beetle prevents any competing weed seeds from getting the necessary light to germinate.
So it's playing defense and offense.
Exactly. And simultaneously, that dense canopy traps moisture in the soil by physically shielding it from the sun's evaporation. The plant engineers its own microclimate.
Wow.
It secures its territory and creates the optimal conditions for its own expansion.
Which makes the bumpy fruit clusters Aang noticed even more interesting in the context of this dense carpet.
How so?
Well, we usually think of fruit as a mechanism to attract larger animals for seed dispersal, right? Like an apple or a berry, something smooth and easily consumed by a bird or a mammal.
Mm-hmm.
But bumpy clustered fruits in the piper genus suggest a totally different reproductive strategy, perhaps relying on different dispersers, or maybe they just break apart in a way that suits a ground cover environment where it's already dominating.
That's a really good point. The observation of the bumpy fruit alongside the quilted leaves, it shows Aang mapping out the plant's entire operational strategy.
Right, from top to bottom.
Yeah, the leaves engineer the microclimate and capture the energy. The growth habit secures the territory. And the fruit handles the localized dispersal. It is complete self-sustaining biological engine, just operating right there next to the sidewalk.
Just doing its thing while everyone walks by.
Yeah.
And, if those quilted leaves and dense roots make it such a dominant survivor in the wild, it makes perfect sense that a gardener with 961 journal entries would find a way to weaponize that resilience for their own garden.
Oh, of course.
Which brings us to the propagation methods Aang details. Because once you understand how this biological engine works, you naturally want to know how to replicate it efficiently.
Right. It's the leap from observation to application. And Aang documents the standard methods first.
Right. Aang mentions the conventional route, taking cuttings and growing them in either water or soil.
The classic method.
Yeah, you snip a piece off, you stick it in a glass of water on the windowsill, and you play the waiting game. But here's where it gets really interesting. Aang reveals a preferred quote-unquote fast-track method, division. And the specific mechanics of this division method rely entirely on understanding that carpet-like growth habit we were just talking about. So mechanically speaking, why is snipping a node that already has roots popping out of it so much faster and more effective than just sticking a regular cutting into a glass of water?
If we connect this to the bigger picture, it's all about biological stress. The methodology Aang describes for this fast track requires deliberate selection. You don't just take any random piece of the plant.
You have to search the stems, you have to actively hunt for specific nodes where roots are already actively growing out of them.
Right.
Once you locate that rooted section, you snip it and transplant it directly into the soil. It's like a biological copy-paste function for your garden. I'm assuming snipping a node with roots already attached skips a massive biological step.
A huge step.
Instead of forcing the plant to panic and build a root system from scratch, you're just stealing an engine that's already running.
That is the exact biological advantage at play here. Let's look at the sheer physiological stress of a standard water or soil cutting. When you sever a stem that lacks roots, you plunge that specific piece of tissue into a severe biological crisis.
It's basically dying.
It is. It has leaves that are actively trying to transpire and photosynthesize, but it has completely lost its mechanism for pulling up water and nutrients.
It's essentially suffocating and dehydrating simultaneously, all while trying to function normally.
That sounds exhausting.
It's incredibly stressful for the plant. To survive, the cutting has to rapidly alter its hormonal balance. It must redirect stored energy away from leaf maintenance and aggressively reprogram the cells at the cut site to differentiate into root cells.
Right, it has to completely change what those cells are doing.
Exactly. That cellular reprogramming takes significant time and energy. And during that entire vulnerable window, the cutting is highly susceptible to rotting in the water or desiccating in the soil. It is a very high-risk waiting game.
But with Eng's division method, you bypass the crisis entirely. You skip the panic phase.
Because of that dense carpet-like growth, the stems of the wild beetle are constantly running along the moist, shaded ground, which is the very microclimate that the plant created for itself with those quilted leaves.
It's a perfect loop. And those trailing stems are packed with root primordia at every single node.
Root primordia?
Yeah, they are basically clusters of cells that are pre-programmed to become roots the moment they sense sustained moisture and darkness. As the plant marches across the landscape, it preemptively anchors itself.
Oh, wow.
It pushes out roots at the nodes to secure new territory and tap into new nutrient pockets before it even strictly needs them.
So when Eng advises finding a node that already has roots popping out, snipping it, and planting it, you are completely eliminating that cellular reprogramming phase.
100%.
The cutting doesn't experience the typical physiological panic because the water uptake system is already fully operational.
Right.
You separate it from the mother plant, put it in the ground, and it probably doesn't even realize it's been severed. It just continues its territorial expansion.
It is the ultimate efficiency. It's a true life hack. But the critical takeaway here is that you cannot utilize this propagation hack unless you first profoundly understand the plant's anatomy and behavior.
Right. The hack is earned.
Exactly. The technique is entirely dependent on the observation. If Eng hadn't pushed past the initial misidentification, if the AI hadn't forced a closer inspection of that carpet-like habit in the rooting nodes, the fast-track method just wouldn't be apparent.
The anatomy dictates the utility. And the utility is only unlocked through disciplined observation. It really is incredible. Let's trace the arc of what Eng actually accomplished in this single journal entry.
It really is a masterclass in the scientific method applied to everyday life.
It is. We started with a casual glance at a roadside landscape and a very human assumption. Oh, that's just piper-betle.
Yep.
But then we encountered the friction of modern technology, where an AI forced a seasoned gardener into numerous reevaluations, ultimately confirming the plant as Wild Betel, piper-sarmentosum.
And that technological friction acted as a catalyst. It broke the human autopilot we all get stuck in.
And once the autopilot was off, Eng moved into that hyper-detailed anatomical breakdown. We explored the dense, low bush structure and the carpet-like growth that allows it to basically dominate the ground level. We visualized the mechanical brilliance of the deep quilted leaves maximizing surface area for light and water management, contrasted with those rough, bumpy fruit clusters.
And finally, we saw how that deep understanding of form translated directly into function. By recognizing how the plant spreads and anchors itself, Eng isolated the most efficient way to multiply it, bypassing the biological crisis of standard cuttings entirely by snipping pre-rooted nodes.
It transforms what most people would call a weed on the side of the road into this highly engineered, deeply understood specimen.
It really does.
And it highlights why someone like Eng makes it to journal entry number 961. The dedication to noticing the small things pays off in incredibly practical ways.
I think the real lesson here is that the environment around us is just dense with this kind of mechanical genius, provided we actually take the time to slow down and look at it closely.
Which leaves us with a thought for you to carry into your day. Eng's relentless curiosity turned a fleeting roadside encounter into a complex study of biology, technology, and propagation efficiency. It's a real testament to the value of slowing down.
Absolutely.
So, if one seemingly common plant can hide that much mechanical brilliance, requiring a stubborn battle with an AI just to uncover its true name, what intricate, quilted details in your own everyday environment are you walking right past without a second glance?
It is a phenomenal reminder to challenge our own assumptions.
Keep your eyes open and question what you think you already know. Thanks for joining us on this deep dive.